So today we're here with Daniel from EleMind and from Disco Research as well. And they have been like one of the early adopters of Distillable, given a lot of feedback on the process and the API and SDK surrounding Distillable. They were intending to create a similar package themselves. Now they are one of the first companies or groups that we invited over to showcase how they are using synthetic data and Distillable within an actual customer use case.
Thank you very much, David. Yeah, I'm Daniel. I am founding Y engineer at EleMind. And today we'll talk about how we leverage Distillable to generate synthetic data for one of our applications. And this is an email reply application that is used in customer service. First, I will introduce a little bit our company. Then I will demo the app. Then I will explain why there is a need for synthetic data in the first place. And then I will showcase a couple of specific examples, how we generated synthetic emails inside our application. And in the end, I will talk about why we decided to use Distillable. So first of all, EleMind came about from members of Disco Research. Disco Research is the largest open source LLM community in Germany. And members of Disco Research released models like EM German, LeoLM, DiscoLM, and Llama 3 German. And combined, these models have over 500,000 downloads on the Hugging Face Hub. We have over 1,000 users on our Discord server. Members of Disco Research then founded EleMind. We began by working on two customer projects, one for a German health insurance company and one for ITZ Bund, which serves all of the federal ministries of the federal government of Germany. And along the way, we built a couple of internal tools, specifically for fine-tuning, synthetic data generation, as well as evaluation. And one of these internal tools we will productionize soon, so keep an eye out for that. Let me demo the real quick for you. So this is an app we built for a health insurance company. And this app assists the customer service in answering emails from customers. We have an inbound email here. In this specific example, it is a customer asking for their address to be changed, and then we can generate an email reply. Our app then fetches important pieces of information in the background from attached knowledge sources, takes these queries, answers them in parallel, and then comes up with an email reply together with the inbound emails as well as the answers. Let me show you the architecture. So we first have an inbound email. From this email, we then extract the customer intent. Based on that customer intent, we generate a handful of search queries. Then we do a retrieval in parallel with and answer these queries also in parallel. Then we collect all these answers, and together with the inbound email, we come up with a final email reply. So why do we need synthetic data in this application? First of all, we had the requirement to use an open source LLM, which we self-hosted. We went with Mixtras having the instruct in the beginning, and we were already quite impressed by its German capabilities, but it wasn't good enough. It needed to be better, specifically in query generation, as well as email answering in German. And we also needed the model to follow a couple of communication guidelines our customer outlined for us. So all of these requirements need to be met, and the model couldn't fulfill all of them right away. So we decided to fine-tune the model. And one further advantage of fine-tuning is that you don't have to rely on private or personal information. You can come up with synthetic data and can then train on non-sensitive data, which is a nice option to offer for customers. Today, I will focus specifically on the first step in our pipeline, on inbound emails, where we use Distillable pipelines for two specific use cases. And also, I will focus on the final stage of the email flow. So for the inbound emails, we were pretty much data constrained. We only had a limited set of email examples, which often were also quite short. So we needed to augment this limited set of email examples, and we devised a method we called eval email, which is inspired by the eval instruct method introduced in the Wizard LM paper. So we basically took a seed example and evolved it to be more complex and more varied by applying a couple of prompts. For example, a prompt which adds a sub request to the email, makes it more colloquial, increases or decreases the verbosity, changes the tone, adds information, or varies the wording. And we also combined up to 2 of these prompts and applied them to the seed examples. On the left-hand side, one such example, which is about the insurance status of employees in the healthcare system. And on the right-hand side, you see the evolved example, which is pretty much the same email, but we added an additional sub request here, which asks for how to handle this process in the future. And evolved them to be more varied and more complex. And this method allowed us to increase the amount of examples from the tens up to the hundreds and thousands, then allowed us to do model fine-tuning. One more approach to generate synthetic emails was to generate emails based on context of information, of chunks of knowledge. We already had them ready in our knowledge sources, in our vector database, and we drew upon sources like the customer webpage or relevant laws. We then pick one specific context. In this example, it's about an electronic healthcare card and electronic patient record. And we then provide an LLM with this context and ask it to come up with a plausible customer request, with a plausible email. And on the right-hand side, we have the synthetic example, which is the customer request, which asks for how to set up this electronic healthcare card. This gave us a very nice variation in our training data, and it also gave us nice coverage over all the topics mentioned in our knowledge sources. Another quite similar approach was to generate synthetic queries. So we basically, again, have our context where we ground our generation in, but this time we generate plausible search queries for the retrieval step in our application. And we use these queries to fine-tune embedding models for embedding retrieval. And since we have the golden context here already paired with a synthetic query, we also could do retrieval evaluation down the line, since we had a query and we very much know which one of the contexts is the correct one for this specific query. We also applied distillable pipelines for our final step, the email answering. We observed here that Mixtral didn't follow all the instructions right away. Specifically, it didn't follow all the communication guidelines because there were plenty of them. To this end, we then took the draft Mixtral came up with and then refined it and reworded it in an extra step. So we had a distillable pipeline for this, which we provided with the guidelines from our customer, the first draft from Mixtral. And then we used a couple of strong LLMs to first generate feedback on the first draft, and then to come up with a final improved version of the email answer. Very much was nice to use because it has nice capabilities of calling models in parallel and having different nodes in parallel in your pipeline, where we could then very easily compare model generations side by side and then decide which one of them was best suited for us. And a couple of these communication guidelines were, for example, to match the customer tone in the introduction, to also have consistent abbreviations of terms across all the terms there were and across all emails, and to always have the same salutation in the end of an email, regardless of the introduction. So these were all little details from the communication guidelines Mixtral didn't get right, so we opted to refine this in a synthetic data step, and then fine-tune the LLM with this improved answer examples. And since we already got used to Distillable at that point, we used it also for a lot of other things. For example, retrieval evaluation I mentioned before, where we looked how well the golden context ranked for a specific synthetic query. And we also used Distillable to do LLM evaluations. So we took the answers and scored them and judged them with LLMs in turn to see how well they did. So why did we go with Distillable? First of all, we are huge fans of Hugging Face datasets. We like them a lot and we use them a lot internally. And Distillable offers a nice, convenient wrapper around datasets called distisets. They log a YAML config file along with the dataset, which contains all the parameters, prompts, and information you need to recreate your synthetic data pipeline. This was very important to us because we experimented a lot with prompts and parameters in our synthetic data generation, and we always wanted these experiments to be recreatable. These tests come with nice dataset cards, which give you instructions for how to recreate and run these pipelines. For this, you can use the Distillable CLI or also call this from within a Python script. Distillable offers a very nice abstraction. It has these graphs with nodes in their pipelines. So we could very much represent the whole application flow inside a distillable pipeline with these nodes as a graph. This allows you to flexibly chain LLM calls, filtering steps, and even steps with arbitrary Python code in them. And you can even call multiple LLMs in parallel, self-hosted ones, local ones, API LLMs, and so on. And this graph structure allows you to be very flexible. And you could also, for example, in the final rewording step, do a cycle where you keep on refining until your generations meet some quality threshold. And you can also branch with multiple nodes like we did in comparing the multiple models. This graph structure really allows you to be creative in your synthetic data pipeline. And since we were quite happy that Distillable existed, we also gave back and contributed a couple of pull requests and added also small features we were still missing. So you can find us there in the GitHub repository. And I also want to highlight a couple more open source projects EleMind is involved in. For example, we recently contributed a couple of benchmarks for the MTAP embedding leaderboard. It has an ongoing community project where multilingual benchmarks are added for the multilingual MTAP leaderboard. And for this community project, we added a couple of datasets, 16 new datasets for retrieval and re-ranking benchmarks, which total 32 new benchmarks in total. And for this contribution, we also used Distillable. We used GPT-4o as soon as it came out because of its multilingual capabilities. And we again did query generation grounded in contexts from the Cohere Wikipedia dataset. This dataset already came with very nicely chunked Wikipedia contexts. I used this dataset to generate queries for them in 16 languages. With this dataset, I then devised two separate benchmark modes. So we had 32 new retrieval benchmarks in 16 languages. And in many of these languages, these are the very first retrieval benchmarks ever. These benchmarks correlated well with human-created ones. For more details, I point you to the MTAP paper, which will be published soon and is currently in writing. And since this was an open source contribution and can go a little bit into detail into the internals, this was the prompt I used inside of Distillable. Your task is to anticipate possible search queries by users in the form of a question for a given document. The question must be written in language. Then I can input the language here. The question should be formulated concretely and precisely and relate to the information from the given document. The question must be coherent and should make sense without knowing the document. The question must be answerable by the document. The question should focus on one aspect and avoid using subclauses connected with and. This was a failure case I observed during prototyping this. The question should not be overly specific and should mimic a request of a user who is just starting to research the document and do not draw on your prior knowledge. So this is not just a string or text file. This is a Jinja 2 template. And I can then here flexibly input variables, for example, a list of examples or an example search query. And of course, the document I'm grounding the generation in. And in the final end, I will then get a search query in the target language I specified early on. Yes, of course, we have more open source contributions at EleMind and at Disco Research as well. For example, our LLMs and also our datasets, which you can find on the Hugging Face sub at Disco Research. And if you're interested in contributing together with us on cool open source stuff, or if you are looking for a job, we are currently hiring at EleMind. Thanks for listening, and I'm happy to take questions.
Cool. Thanks for the overview. It was nice to see the general pipeline and the outline. Maybe one question to start with. You mentioned that the MTAP stuff was open source. Would you be able to share the GitHub URL or maybe some of the team?
Yes. I think it is not open source yet because I branched one of our internal pipelines, but I can open source it since the paper will be published anyway. Soon I can open source it. So yeah, as soon as the paper will be released, we will do a post online and then you can take a look at the repository.
Okay, thanks. Then there was one question from Chirac. He was curious to understand what type of fine tuning was done on the Mixwell LLM. Did you use LoRa or some of these techniques, or did you do full fine tuning?
Yeah, we did a LoRa or a QLoRa. I'm a bit unsure at this point, but yeah, just we went with LoRa and just axolotl, the tried and tested approach, and yeah, did parameter efficient tuning there.
Also, if someone has a question in between, feel free to raise your hand. And the question is, what are you using for the self-hosting, I guess, for the LLM? Are you using like Ellamind, text generation inference?
Yeah, we are using the LLM as inference server, and we're hosting it with a European cloud provider. And yes, the LLM as inference server.
Cool. Which European cloud provider?
So this is OVH from France. And
yeah, nice to hear that. Then there's a question from Stefan. Could you go more into detail how you fine-tuned your embedding models based on synthetic data? Which base model did you use? Did you generate one or more synthetic questions per document chunk? And how did you create negative examples?
Yeah. So we fine-tuned all of the sizes of the 5, I think, embedding models from Infloat, the Microsoft release from late last year, from December or from winter or autumn, are quite robust, I would say, and are widely used and lend themselves quite nicely to fine-tuning. We fine-tuned all of the sizes, small, base, and large, and we generated 1 or 2 queries per chunk. Yeah, maximum 2, not more, I think. And negative examples, how did we come up with negative examples? I'm not quite sure now, but maybe we might have used some sort of similarity threshold above us, or yeah, I'm seeing Björn, our CTO, maybe. Do you recall?
Hi. Yeah, we did not use negative samples for the fine tuning as far as I can recall. It's possible to do fine tuning without the negative examples if I remember correctly.
Thanks for helping out, Björn. And one more observation I can share is that we also benchmarked the embedding models, and we saw that the base model or even the small model was performing almost as well as the larger models. So in this specific instance, in this specific use case, we went with a small model in the end because there was really a negligible loss in performance compared to the larger models, which shows you how far embedding fine-tuning can go.
Cool to hear that. I think we also played around with that ourselves a little bit with like STK chatbot that we recently released. Then there was one put question from Manek Xerox. How much impact did generate the addition of synthetic data with Distillable in your pipeline? Is there any secret sauce that you could share to make the most out of the Distillable library?
Yes. If you run into troubles, so sometimes this label works well most of the time, but sometimes it can be that an error message doesn't make sense right away. So for this, I found a way to debug it very easily. If you run into troubles with this label and there is an error message where you can't make really sense of it, you can go into the GitHub repository and search for the issues. For one of the issues I created, and there you can find a good way for how to debug it. But it might also be that this is already fixed in one of the later versions.
Does that answer the question, by the way? Or otherwise, feel free to.
I'd like to know, especially when dealing with synthetic data, that with the LLMs in the field, the quality of the synthetic data has increased by a lot. And I'd like to know if in the metrics that you evaluate, how much did it improve the overall library science studies synthetic data generation?
So you're asking how we measured the fine tunes and compared them with a vanilla model, am I right?
Yeah, something like that. So how much delta are you in any metric or in your use case are you winning thanks to adding this new variation of emails or in this rephrasing or writing some if you could evaluate that and if you could share some numbers with that, that'd be great.
Yeah, I can't share a number specifically because the improvements were quite subtle, but still very important. It improved in the details, for example, like in a German wording, which is not that straightforward to measure. And also the instruction following of all the guidelines. This was also very well improved. Mixtral didn't get it right away, but in these details, which we didn't measure numerically directly, we went in this case like with observation and type checks. And these specific details, which are subtle but were still super important to us, it very much improved.
All right, thank you, Remy.
Yeah, and I think one of the benefits of synthetic data is, of course, also that you don't need to use human annotators or less human annotators. So you can just start off with your initial type checks and then look at the outliers to focus on, similar to whenever you would train a classification model. Then there was one question from Steve Kramer. If there's any specific links of Distillable pipelines and one showing calls to multiple LLMs or any arbitrary Python code. I believe we have these examples within our GitHub repository. And this is also something that whenever someone feels that there's too little examples of distilable pipelines, also feel free to create an issue on GitHub and I reach out, say, okay, there should be more tutorials. There should be more examples about using like multiple LLM calls or creating custom components or this kind of thing. Because then we also know that we can focus on that and for us, maybe more intuitive, so to say, than for you guys. I'm not sure if you have something to add about specific code that you might be able to share, Daniel.
We don't have examples ready or public. I might not be able to share something along these lines, but the documentation is quite good at this point, the updated documentation. So you can go there and specifically look for the steps. These are steps we use very often, and therefore you can define arbitrary Python code you can use.
Great, thank you so much. Appreciate that.
You're welcome.
Thanks. So within the GitHub repo, there's some examples of pipelines, and also like within the documentation itself, some examples of actually paper reproductions that we've done, and also some like general examples. So, for example, using outlines for instructor to actually work with Distillable or within Distillable.
Yeah, I want to point out that the paper reproductions are very instructive and very nice examples. Take a look at them.
Cool. Nice to hear that. I will forward it to the rest of the team as well. And then how many evolutions and these kind of things did you use for evil email? Because normally you evolve your prompts once and then again and you compare in between. What did that process look like?
Are you still around? Björn worked mostly on the evil email.
I'm still around. Hi. So for this, we did a few different experiments, and the best one was actually a single evolution step because we found like chaining different evolution types or applying the same one at multiple times led to a bunch of weirdness. I think the email format and the specific domain of email format is already difficult for the model. Basically, changing the tone to be nicer and afterwards changing the tone to be more lax or something often led to really weird wording. So we chose a subset of evolutions that are applied once and also a very small subset of evolutions that can be applied together at random, where we found that they work well together. For example, changing the tone to be more formal, but also adding a sub-request.
And the thing about getting weird results when doing multiple evolutions, that's also something that I've seen. And maybe based on the fact that the paper was also original paper written around the time and research also with a less quality data set, so to say. And then you actually have more to gain from rephrasing than nowadays with models being generally able to produce higher quality outputs.
Yeah.
And then after a while, the evolution doesn't improve that much anymore either. And then you just are like spending a lot of tokens compared to like the gains that you'll end up getting.
Yeah, I think in our case, the evolution step was less to improve the quality of the incoming samples because we were evolving like the input basically, and more to diversify and increase the breadth of our fine-tuning data set to incorporate more diverse incoming requests. and different types of wording and all that to make sure that we're not like limiting ourselves to a small distribution. And then some more natural mail comes in and the thing totally fails or whatever.
That makes sense. How did you end up deciding on using Mixable as a model? And yeah, how would you recommend maybe people looking at like open source models or finding their right open source model for their use case? Is there anything you can share about that?
So we went with Mixtral 7B Instruct or 8B Instruct with in the beginning as we started developing the app, because it was then SOTA or one of the stronger open source LLMs out there. But we are planning on swapping it out, maybe for Llama 3, either 70p or Quen model, quantized version, because we observed so far that a large model, a quantized one, still could fit in our GPU and still generate quite good email replies. We might switch out the model there. And for this, we are still relying on the LLM. And in principle, you can switch out the models there. Although if a model is quite recent, then it might not be fully supported with the LLM. And then you might have to fiddle around a little bit, maybe pull the main branch and build it from source. So with very recent models, there are sometimes some hassles, but yes, you can get it working.
And I was wondering, there was one more question, rewriting of the initial prompt. So besides the evil email, you were also rewriting responses or the response emails. Is this like a special implementation of the evil email, so to say, or like a fully custom step?
So this is a separate step, which we did in the end with the drafts. Mixtral came up first. And then we took a stronger model and we worked together with the communication guidelines. Because the stronger LLMs, some of them were better in German, breaking the step down of coming up with a draft and incorporating the communication guidelines, breaking this down only allowed us to really have the correct, nice response in the end.
Thanks. And maybe in the end, how would you compare like self-hosting a model and along with all of the API calls for the different steps in your pipeline and also the synthetic data in between versus OpenAI API calls or cloud OpenAI calls outside of the obvious like privacy and these kind of benefits that you get from it? And is there some like cost estimate or something that you keep track of in terms of reporting to your client as well?
When it comes to usability, there aren't really any drawbacks because most of the inference servers out there nowadays provide an OpenAI compatible API. So it really makes no difference. You can even instantiate the normal regular OpenAI client and just change the base URL. And from this point, it doesn't make any difference. And why synthetic data generation with self-hosted models makes also sense is you don't have to worry about any licensing issues. It can cost less because you self-host and you have a high throughput, and this might end up cheaper in the end than paying API credits. And when it comes to hosting costs, I think Björn or Jan can give more insight on that. I'm not fully in the picture.
With regard to hosting costs, we're on a slightly tight budget there, but I think normal cloud GPU costs, we're going with one H100 as I think our, for Mixtral, we were using a different configuration because it's so memory heavy that it doesn't fit in the H100, but the speed isn't an issue with the model. So I think for the Mixtral hosting, we went with a 4X E100S server setup, which is like older GPUs and older CUDA version, but it worked fine and it was like cost benefit payoff, or I guess cost memory payoff, the most efficient implementation for quantized models.
Okay, thanks for the answer. It's also something that we did mostly when fine-tuning models on our side, just get more models from cheaper GPUs and then you have more GPUs, but then the cheaper variants. Then you end up saving quite a bit of money. Also takes a bit more time, but it's worth it. So then if there are no more questions, then I would like to thank Daniel and of course the rest of the EleMind team and everyone for coming by. Hope to see you again. In a couple of weeks, we'll likely do a meetup together with ZenML, also optimizing RAG pipelines. But then maybe go a bit more into ZenML and some open source distillable code specifically for that.
All right. Thank you. This was fun. See you.